Let's start section 10.2 and talk about the law of cosines. The law of cosines is another tool that will help us to solve triangles. And in this video, we're going to focus on the derivation of the formula. And in later videos, we'll work through some problems. So we will again label the angles of a triangle with Greek letters alpha, beta, gamma, and the corresponding sides with the letters A, B, and C. So A is across from alpha, B is across from beta, C is across from gamma. And to derive the law of cosines, we need to recall something called the distance formula that gives the distance between 2 points x1, y1 and x2, y2 in the xy plane. This formula is derived from the Pythagorean theorem. We're not going to derive it here, we're just going to make use of it. The distance between these 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's go ahead and start deriving the law of cosines now. And what we're going to do here is we're going to take our triangle, so the typical triangle labeled with the angles labeled and the sides labeled, but we're going to put it in a particular position with side B. We're going to place side B along the x-axis in a coordinate system, and we're going to put the angle gamma at the origin. So we can always place whatever triangle we have in this kind of position. Now, there's a few things we can observe here. One is if this length is b from 0, 0 out to this point right here, this point on the x-axis has to be at b, and its coordinates are b comma 0. And now what we're going to do is we're going to add something to this. Oh, let's label a little bit more here, sorry. What else do we know? Let's see, if this is angle gamma, across from gamma, this has to be side C. And let's see, the other side then has to be A, because we got CB, this has to be side A. And across from side A has to be angle alpha. And I'm not going to actually put angle, I guess I could put angle beta in this picture is up at the top. But what we're going to do here is we're actually going to draw the height h down from the upper vertex. So we're going to cut that angle beta into pieces. And I'm going to draw a height straight down, so perpendicular to the x-axis. And I want to label that height h. And I also want to give a name to the distance that goes from the origin 0, 0 to this spot where the height h touches the x-axis. We're going to call that g. So if g is this distance, this horizontal distance, and h is how long this height is, then the coordinates up here at the top are going to be g comma h, because this is the same as its x-coordinate, h is the same as its y-coordinate. Okay, so now what I want to do is I'm actually just going to look at a piece of this picture now. I'm going to kind of pluck off this right triangle that has the angle gamma, that has the hypotenuse now as A of this right triangle, and one side is H, one side is G. And what I want to do is I'm going to describe the sine of gamma using SOHCAHTOA. Sine of gamma using SOHCAHTOA is opposite over hypotenuse So in this triangle, it's h over a. And I'm also going to describe cosine of gamma. Adjacent over hypotenuse in this right triangle is g over a, g over a. And then I'm going to take these equations and I'm going to multiply both sides by a here to clear fractions, multiply both sides by a here to clear fractions, and I end up with a times sine of gamma equals h, and this a also cancels. I get a cosine gamma equals g. Okay. Now, here's where we're going to make use of the distance formula. We're actually going to think of this side c. So we're going to take c from the picture all the way up at the top. So that c right there is the equal to the distance from the point B0 right here to GH. So C is equal to, I'm going to plug those coordinates into my distance formula. So I have the square root of the difference of the x coordinates, so it's going to be g minus b squared, plus then I take the difference of the y coordinates, h minus 0 squared. And then I'm going to square both sides. And so I'll get c squared on the left. And when I square the right-hand side, the square root sign will go away. I'll still have g minus b squared plus, really that's just h squared, right? H minus 0 squared. Now I'm going to make a substitution. I'm going to go back up to these equations I got earlier where I know h is equal to a sine gamma, and I know g is equal to a cosine gamma. I'm going to replace h and g with the expressions in these boxes. So I can say c squared is equal to, instead of g, I'm going to write a cosine gamma minus b squared, plus then instead of h, I'm going to write a sine gamma squared. And now I'm gonna multiply this stuff out on the right. Now what I have here is a square of a binomial. It's a cosine gamma minus b times a cosine gamma minus b. And so that's, if you want, you can think of that as a FOIL multiplication problem. I have c squared equals, so I take a cosine gamma times a cosine gamma as a squared cosine squared gamma. Outside I get minus ab cosine gamma. Inside I get minus ab cosine gamma. So I'm going to get minus 2ab cosine gamma plus b squared. And because that's negative b times negative b is plus b squared. And then, so that came from the square. The first part, I still have plus this a sine gamma squared, which I can write as a squared sine squared gamma. Okay. All right, now I'm going to rearrange things a little bit here. Let me move over a little bit too. I'll write c squared equals. I'm going to write these two terms next to each other. So I have a squared cosine squared gamma plus a squared sine squared gamma minus 2ab cosine gamma plus a b squared. And what I want you to see here, what we want to look at from these two terms is I'm going to factor out an a squared from just those two terms. So I have c squared equals a squared. There's a reason for doing this. I can factor out an a squared from those two terms. I'm going to have cosine squared gamma plus sine squared gamma minus 2ab cosine gamma plus b squared. Finally, something kind of nice is going to happen to us here, because what's inside that parentheses, cosine squared gamma plus sine squared gamma, has to equal 1, because that's our most famous trig identity, the Pythagorean identity. So cosine squared plus sine squared for any angle is always equal to 1. So that simplifies a bunch of stuff here. We got c squared equals a squared, I'm just going to say times 1 minus 2ab cosine gamma plus b squared. And I'm almost there. Switch to a new page. I'm just going to rearrange things a little bit here. Whoops, let's just write c squared equals a squared. I'm going to put the plus b squared term next, minus 2ab cosine gamma. And that thing is pretty much, that's the law of cosines. It's a law of cosines is a big, messy formula. Similarly, there's actually more to it. We have the following. Now, in that derivation, there was really no reason why I had to put gamma at the origin. I could have put the angle alpha at the origin, or the angle beta. If I put alpha at the origin, I'd get a similar formula, but I'd actually have an a squared equals b squared plus c squared minus 2bc cosine of alpha. It would be a formula that involves an angle alpha. If I had put beta at the origin, we would get the formula b squared equals a squared plus c squared minus 2ac cosine beta. Now that's not obvious. I'm not going to go through all those steps. I'm just sort of stating that for a fact. So there's actually these three separate forms of the law of cosine, and they can be kind of intimidating staring at these. Well, luckily, you don't have to memorize them. I will give you these formulas to work from in my class, but I do want you to try to see that there's a certain pattern going on here. And one part of the pattern is that the A and the B that occur here match the A times B that we multiply there. In the other forms where we have, say we have a B and a C in that position here, we have a B times C right over here next to it. If we have A and squared C squared here, we got A times C next to it. And the other thing to recognize is that the C squared in front, in this form, corresponds to the angle gamma on the end. If we have A squared in front, we have the cosine alpha angle on the end. If we have B squared in front, we end up with the cosine of beta angle on the end. So in my mind, these are sort of three different ways of saying the same thing. And let's sum it up now. So this is, I wrote this ahead of time. I just recopied those three forms of the formula of the law of cosines. And we're just about ready to go ahead and do some problems. But I want to just say, before we apply this thing, I want to say just a couple more things. And one is to put the law of cosines in words, because there's really no magic here to the letters that we use, A, B, C, alpha, beta, gamma. So just, I want you to try to take this in. If I put this law into words, we would say the square of one side of a triangle equals the sum of the squares of the other two sides put a comma there, minus twice their product times the cosine of their included angle. So you can, you don't have to, I know that's quite a mouthful, but I just want you to see that we can word the law of cosines with no actual reference to particular letters. It's just a very general statement that's true no matter which triangle we choose, as long as we get things in the right order. The square of one side here is the left-hand side of the equation, equals, the words refer to the equal sign. The sum of the squares of the other two sides, that's like the a squared plus the b squared in this first equation, minus the minus sign, twice their product, 2 times ab, times the cosine of their included angle, cosine of gamma, in that first form. And just again, so there's the law of cosines in words. I guess I got room here for a little bit more. Just one special case. If the angle gamma is 90 degrees, if gamma is 90 degrees, then our triangle is a right triangle. So say that's gamma here, alpha here, beta here. So if gamma is 90 degrees, then we have a right triangle. And let's label my sides. A will be here, B will be here, C is here, with hypotenuse C. Right, because C has to be across from the gamma angle. So let's just look at what this law of cosines in that first form is going to give us here. We got c squared equals a squared plus b squared minus 2ab cosine gamma. So c squared equals a squared plus b squared minus 2ab. That's cosine of 90 degrees. But cosine of 90 degrees is 0. So we have c squared equals a squared plus b squared minus 2ab times 0. Well, that makes that whole last term equal to 0. And we're left with just c squared equals a squared plus b squared. That's the Pythagorean theorem. So I think you probably wondered how it kind of looked like we had a c squared equals a squared plus b squared buried in this complicated formula. And what happens is, if gamma's 90 degrees, if we have a right triangle, this one of these equations will just turn into the Pythagorean theorem. We think of the Pythagorean theorem as a special case of the law of cosines, or to turn that around, the law of cosines is considered to be a generalization of the Pythagorean theorem. So up next, we'll do some problems.